Okay, this is your extra credit review video, and I want to start by showing you the formulas exactly like they will look on quiz day. And what I have here across the top are the arithmetic formulas. So I'm going to kind of draw a little line right here. And you can see this is explicit. And this is your summation or your series formula. And then all of this up here is arithmetic. So what I would suggest is you guys pause the video and kind of copy all this down on the back of one of your pages, or maybe at the top of one of your pages. So this section down here is geometric, or all of our geometric formulas. This is explicit. And probably one of the trickier things is knowing when to use which one of these two formulas. This is summing through the n term, or the nth term, so this will be finite. When your sequence or your series actually ends at a certain term position, this will be infinite. But infinite is only going to be used when your absolute value of your R is less than 1, meaning that you have a decay type of problem that is decreasing and approaching 0. And it could actually be where it's a negative R, and you're kind of flipping back and forth between positive, negative, but either way, it's decaying and approaching 0. So that is how you'll know you can use this formula when the absolute value of R is less than 1. Okay, so I want to do some of the problems from the worksheet. Okay, so here we go. Let me kind of get situated here. So what I have here are, this is basically a recursive formula, which we won't do much of, but basically this is saying that if I want a term, say the 5th term, I would look at the 4th term and multiply it by 3. And they're giving us the first term of 1, so we're literally just going to start with 1, then we multiply by 3, so this is basically saying this is geometric with a ratio of 3, so it'd be 3. It would be 9, it would be 27, and then it would be 81. So I'm just basically practicing writing the sequence out. Okay, the next one is, you can tell it's a line, so this is going to be arithmetic. So I'll kind of put a G here, I'll put an A here, and we want the first 5 terms. So if I want the first term, I have to plug in an n of 1. So negative 2 times 1 is just negative 2, so I'm going to start with 4. And to me, the easiest thing from there is just to subtract 2 every time. So that's going to be 2, 0, negative 2, negative 4. So this is arithmetic with a common difference of negative 2. Now, the next one is saying that you have your first value of 1, and you're going to add 4 to get to every subsequent value. So it'd be 4, 8, 12, and 16. So those would be the first 5 terms there. All right, so that's just kind of a little easing into the whole process by setting up the sequences. So it says write a possible explicit rule for the nth term of each sequence. So the nth term. So first we need to determine, is it geometric or is it arithmetic? So here we're adding 8, we're adding 8, we're adding 8. This is definitely going to be arithmetic with a common difference of 8. So my explicit formula will be A sub n is equal to my first term of 8 plus, and it just happens to be a common difference of 8 as well, and then it would be n minus 1. So that's how you do that. So this is your first value, and this is your common difference. Now, on the next one, it appears that maybe I'm multiplying by 0.2 every time. Now, how would I figure that out? I'd actually do division. So I do 1.6 divided by 0.8. So it's actually multiplying by 2. So this is a 2. Do 0.8 divided by 0.4, you also get 2. So this is geometric with R equal to 2. So my formula is going to be G sub n is going to be the first term of 0.1 times my R of 2, and then it's n minus 1 for the formula there. All right, the next one. I have a 3, I have a 6, I have an 11. So let's see what's going on here. So here from 3 to 6, I'm adding 3. From 6 to 11, I'm adding 5. So is this arithmetic? No, it's definitely not, because once we're adding 3, the next time we're adding 5. So let's do some division. If I do 27 divided by 18, I get 1.5. If I do 18 divided by 11, I do not get 1.5. So this is neither type. I cannot do this one. All right, the next little series or sequence here is 3/2 and 3/4 and 3/8. It looks like I'm multiplying each time by 1/2. So kind of test that out and see. 3/2 times 1/2 will give us 3/4 times 1/2 will give us 3/8, etc. So this is geometric with r of 1/2. So G sub n is going to be 3/2 times my r of 1/2 to the n minus 1. Okay, on to number 8 here. It looks like from -2 to 1, I'm adding 3. Adding 3, adding 3, adding 3. So this is arithmetic with a common difference of 3. So arithmetic, I'm going to take my first term of -2. I'm going to add 3 and then n minus 1. Moving on to the next one. If you can't really tell, remember how you can do 0.008 divided by 0.04, see what you get. 0.04 divided by 0.2 and see what you get. And these would have to be the same common ratio. So I get 0.4 here. I'm sorry, 0.2 here. And I believe I'm going to get 0.2 here. So yes, this is going to be geometric with a common ratio of 0.2. So G sub n is equal to my first term of 5, 5, and then I have my 0.2 as my ratio, n minus 1. So those are all just kind of writing out the explicit formula based on the sequence that you see. Okay, the next section. Determine whether each sequence could be geometric or arithmetic. If possible, find the common ratio or difference. So the first one I look at, it looks like there's definitely a pattern. So let's just do the division. 89.1 divided by -29.7 and see what I get. -29.7 divided by 9.9 and see what I get. So 89.1 divided by -29.7, and I get a -3. Now, if I look at the first one, that does fit that initial pattern as well, but let's just double check this, -29.7, and divide that by 9.9, and I get a -3. So this is definitely geometric, and ratio is a -3. Okay, the next one. It looks like I'm going to be adding 9 every time. No, wait, from here to here, it's 11, sorry. So it looks like it's arithmetic, so if I take -18 plus 11, I get -7 plus 11, I get a 4 plus 11, I get a 15. So this is arithmetic, and your common difference is going to be 11. Now the next one. So here it's doubling, so multiply by 2. Here it's multiplied by 3. Then it's multiplied by 4. So there is definitely a pattern, but it's not either of the patterns that we have learned. So put a neither there. And it looks like we're subtracting each time, but it changes every single time. So let's do some division. 1280 divided by 1600, and I get 0.8. Let's do 1600 divided by 2000, and I get 0.8. So this is going to be geometric with a common ratio of 0.8. Okay, so that's just kind of identifying which sequence it is, which type, and then figuring out your R for geometric or your D for your arithmetic. All right, so find the 10th term of each geometric. So they're already telling us this is geometric. Let's review our little formula. G sub n is equal to G sub 1 times R to the n minus 1. So if we want the 10th term, we're every single time going to be doing G sub 10, and we're going to do 10 minus 1. The problem is we don't know, well, we do know G sub 1, there it is, but we don't necessarily know R, so let's figure that out. So they already told us it's geometric, so all I have to do is do 216 divided by negative 144, and that's going to give me an R of negative 1.5 or negative 3/2, however you want to look at it. So I'm literally just going to plug this in the calculator and see what I get. So that'll be raised to the 9th, and I get 2460.38. 2460.38. Okay, the next time it looks like I'm multiplying by negative 3 every time. So I'm going to have G sub 10 is equal to my first value of 2, then a negative 3, and then to the 10 minus 1. So my starting value, I have my common ratio of negative 3, and then I'm looking for the 10th term. So I have to multiply by this negative 3 9 times. And we've talked about that in class a lot. So just do this in the calculator, and you get negative 39,366. So find the 8th term of each geometric sequence with the given terms. Now, this is a little bit more involved because we don't know R and we don't know the first term. So how am I going to do this? We did a sum in class. You have to kind of think of it like this. I know the 3rd term is 12 and the 6th term is 96. And I know that if I start at G sub 6, sorry, I'm going to actually start at G sub 3 and end at G sub 6. I said that backwards. And then I have my common ratio that I don't know, but I know that I need to make 3 multiplications because 6 minus 3 is obviously 3. So how am I going to solve for this? Well, I just plug in G sub 6. So 96 is equal to 12. And then R raised to the 3rd power. So I'm going to divide both sides by 12. And I get R cubed is equal to 8. So then R is just going to be equal to 2. So in class we did this where we raised both sides to the 1/3. So that will cancel. But you can mostly see that R is just going to be a 2. Now, that's not what it really asks. It wants us to find the 8th term. So what I have to do is work backwards to find my first term. And I know if R is 2, that I could just divide by 2 and get 6. And then divide by 2 and get 3. Or let me just write that out because I'm afraid I probably lost some of you on that. So if A sub 3 is 12, and I know I'm multiplying by 2 to get to the next term, I could divide by 2 to go backwards. So that gives me 6 here, divide by 2 there, and that gives me 3 there. So G sub 1 is a 3. So just using the formula, I'm finding the 8th term. So I want G sub 8 is equal to 3, which is the first term, my common ratio of 2, and then I'm going to raise that to the 8 minus 1. So it's going to be 3 times 2 raised to the 7th power, and that's going to give us 384. Okay, so same thing with this scenario. So I know the 15th term is up 100, and the 17th term is 25. So I want to know what happens to turn 100 into 25. But I'm only doing it 2 times because it's 17 minus 15. So this is kind of tricky because the numbers are getting smaller. So let me kind of write this out. So if I know the 15th term is 100 and I know the 17th term is 25, you guys might even be able to see what's happening. So it looks like it's multiplied by 1/2. But let's go ahead and solve it. So I divide by 100 and I get 1/4. So R squared is equal to 1/4. Okay, so what am I going to do? I'm going to basically take the square root of both sides, and when I take the square root of 1/4, I do get 1/2. So R is 1/2. Okay, but I still need the first term, and this value 15 is so far from the first spot, I'm going to need to use the formula for this. Okay, but since I know R is 1/2, what I can really do is pick either one of these two pairs. So I'm going to say if I know the 15th term is 100, I don't know my starting term, I know my ratio is 1/2, and I know that this value of 100 is the 15th, so I'm going to do 15 minus 1 here. So what I have to do is I have to divide both sides by 1/2 to the 14th power. So 100 divided by 1/2 raised to the 14th power is going to give me a really big number. So I'm actually starting with G sub 1 of 1,638,400. So it's going to be 1,638,400. And I want the 8th term, so G sub 8 is going to be the first term. And then I have my common ratio of 1/2, and I raise that to the 8 minus 1. So I'm just going to take what I just got in the calculator, and I'm going to multiply that by 1/2 raised to the 7th power. And and I'm going to get 12,800. So that is your final answer there, 12,800. Okay, since this was sort of long, I'm going to go ahead and do the next part of the extra credit video tomorrow. So I'll go ahead and pause that, and that's just kind of the first half of everything we learned this unit.